In this module, we're going to be talking about the heating system of the laminator. Now, the heating system is what internally heats the rollers on the machine. You're going to have possibly machines that have no heat. You're going to have single heat machines or top heat assist machines, and also dual heat. For the purposes of this training, we're going to be mainly dealing with dual heat machines. I'm going to try and show you some of the common components and the theory of operation and some of the things that commonly go wrong. But what I will say is that the number one cause of heating problems on laminating machines, in my experience, is faulty connections. I can't say it too many times. We just want to make sure that we're practicing good safety whenever we're working on these machines. So whenever possible, you want to have the power and air removed, and also be mindful of the fact that some parts may be under spring tension. Now, we all know as technicians there's going to be times when you'll need to make an adjustment or test something while the machine is under power. So during those times, you need to use just an extra measure of safety and care, and also be mindful of anybody that might be working with you around the machine. So what I have here is some of the common parts that you're going to find over and over again in these type of machines. And number one, we're going to talk about the heater. There's two types that have been used over the years. One is a glass tube heater. So this is in essence a lamp that heats up, and these heaters get very hot. I've been told 1600 degrees, and that heat radiates out through the roller. So this one is a glass tube type. This one is a rod type, what they call a cowl rod type heater. And this is very similar to what you might see in your electric range, in your oven. So this one just happens to be straight. So one of the disadvantages to a cowl rod type heater is that it sags over time. These things expand. As a matter of fact, a heater this size may expand almost up to an inch when it heats up. And so as it expands and contracts, has a tendency to sag in the middle, and that's why you might see in the mounting some type of spring. So that spring needs to be compressed while the heater is cold, and that way it pulls it straight as the heater expands. Glass tube type heaters do not sag, but they're breakable, and so a lot of machine manufacturers have gone away from using the glass tube. I do believe Seal is still using it, but it's very breakable, and so it makes the machines hard to ship and the parts hard to ship. This is actually a heater that has gone bad, so if you pull the heater out of the machine, you may see something that looks like that, and that's an obvious failure. The glass tube types, you'll see discoloration and a black spot in the heater where it's burned out, sort of like a light bulb. The next most common component is something that's called a solid state relay. So this is what's used to turn the power on and off within the machine. Almost every wide format laminator uses solid state relays. The next is the heat control. Now, what this does is it takes input from some type of heat sensor, and I'm going to show you some of the different ones on the machines, and determines whether or not to turn the heat off and on. And it does that by turning off and on the solid state relay. So on the solid state relay, you've got a connection for a low voltage signal from the temperature controller, and a connection for the wires that run to the heater. Now we're going to talk about how the heating system works. I'm going to point out the major components and give you some theory here, and also tell you some of the things that might go wrong. Your heat controllers are right behind the heat display on the control panel, and you've got a top and a bottom heater or heat control. You've also got your solid state relays here, and this is where your heaters connect. So your temperature controller is going to have power to make it run. It's going to have inputs from a temperature sensor of some kind, and I'll show you that in a minute. And it also is going to have an output that goes to your solid state relay. Usually that's a 5-volt signal to turn the heat on and off. The temperature controllers are usually pretty reliable, but especially if you're working with a dual heat machine, you can switch those to see if you've got a problem there. Your main source of problem here is going to be the connections to the heaters. So if you pull these sheaths off, you're going to see where the wires connect, and if you have any arcing or the wire is broken, that's obviously going to be a problem. As far as the solid state relay goes, usually if they go bad, they are shorted. So in other words, the heater will run all the time. It won't turn on and off. And they do get quite hot. You'll notice if you take one of these off, it has a heat sink material on the back of it. So most of the time we see them is when people are using the heat on the machine a lot. One other thing that I'm going to point out on this Seal 600 here is these temperature or thermostats that are attached to the roller bearings. There's one on the bottom and one on the top. Those are your overheat protect on this machine. So what that does is if one of those bearings gets too hot, it will send a signal through this little relay here to turn the heat off. So it is possible that if one of your heaters isn't getting the signal to turn on and off, it may be because of that temperature overheat thermostat. The Seal 600 uses a contact type temperature sensor. It's located right here next to the roller, and that actually touches the side of the roller, and that's how it gets its temperature to feed back to the temperature controller. If you power up your machine and you see something close to what the room temperature is, that's usually a pretty good indication that your temperature sensor is working, and also probably the temperature control is okay. And so now we're going to take a look inside the Orca, and incidentally the Falcon 60 Plus is almost identical, so we're not going to go over that one, but you're going to see some familiar parts and pieces. You've got temperature controllers, solid state relays, and some solid state relays do have a light on them that will help you troubleshoot whether or not you're getting the signal to turn them on and off, but not all of them have that. The big difference here with this design is they use an infrared sensor, so there is no contact with the roller. It's just a sensor that points at the surface of the roller and picks up the temperature and feeds back to your temperature control. And there is no overheat protect on this machine. They use the temperature controller and what's called an alarm setting that goes in there. So if it reads a temperature above, say, 320 degrees, it's not going to provide any signal to turn on the heat. The biggest cause of problems is bad connections to the heaters. So now we're looking inside a Seal 62 Pro D, and you're going to see very much the same setup as on the Seal 600. You've got your temperature controllers up top here, heaters, and this machine does use the glass tube type heaters. You've got down below, it's out of the camera view, but you've got two solid state relays down there, and then you've got thermostats on the roller bearings to act as the overheat protection.